Let's see serialize and deserialize binary tree problem from the LeetCode. This is the hard problem. So let's try to understand. So for this, uh, we are given the functions to serialize and deserialize. So when we serialize this, we need to write some algorithm where we can put all this data to the string. So we can either traverse in order, preorder, or any order traversal. We can traverse that and collect this data and put that in a string. And once you put that string, the next function you need to write, that we need to convert that to a this binary tree. So when we write that algorithm, that is called deserialize. When we get back to the node and when we get all the items in a string, that's we call the serialize. So we can use any traversal here. Also, if you see the note here, you do not necessarily need to follow this format. So this format, maybe this format, we can utilize anyway. So for now, I'm going to use preorder traversal here, and I just traverse the preorder, collect one. In a preorder, go to the take this value, go left right. So I'll take this value, put that in a string array. Again, take this value, put that in a string array, and down here there is nothing, this 2, so I can just put the 2 nil. So for the nil, I can just put any character. I can just say n for nil, so I put the n, nil or null in a Java. And in the same way, I get all the strings. And when we construct again, I will just go through, iterate, that string, each value in the string, and whatever the first value I get, I put that in a new node. I'll construct the new node, and again I need the left value. So for the left value, I call recursively the function, and again that function again call recursively the same function, and get the item from the string array one by one, and we can call the left and right direction, and we can create this row. So let's understand this thing a little bit more. I'll just jump to the another screen for this 1 2. So what I'm saying, first, when I see this 1 in a pre-order traversal, I will get this 1. Then in a pre-order traversal, we know first, then we take this 2, so I'll take 2, and from this n, I just put 2 null here. Go to the right side, and from the right side, I'll collect 3, and this pre-order traversal, again we go this place 4, collect 4, and below this 4 there are nothing, then I can put 2n for the left and right, then come to this place 5, and here also there is nothing, so n and n. So that's the string, that's the serialize. So we'll able to write this function easily, and we can get this string. And from this string, we need to write the deserialize function, where we can construct this this binary tree. So when I iterate through this, I will maintain one global variable I, and from 0, when I first I get 1, I'll construct one node, and in that node I can put 1, and then after that I need the left value, and also I need the right value. So for this left and the right, I will call this function again, and when I go to the left, I will get the 2, so I'll put the 2, and for this 2 again it will call left and right. So left and right there is a nil, so we'll find the n. For left and right we find the n, and for the n we'll put the nil in this left and right. So 2 is done. For the one left portion is done, remaining right is remaining. Again, from iteration from our string we'll get 3, so we'll just put the 3 here, and from the iteration again we'll get the 4. So in a pre-order traversal, first we go to the left place, so I'll come here and put 4 here, and for this 4, after 4 there are 2 n, so go to the left and right and put the nil there, and there is a 5 after that. So the left recursion is done, for this 3. So I'll go to the right side, and the right side I can put 5, and again there are 2 n, so here I can put the n, and in that way I can construct this this binary tree. So yeah, that's the logic I'm going to use, and this is very easy code for this. So let's see the code. Yeah, before this code we can see here how it's getting called. It will first call the constructor. So there is a function constructor that was empty, and for this constructor it's going to return the codec, this struct codec, and this codec has two functions, serialize and deserialize function. So when we call the serialize, it will return the string from this, and when we call the deserialize, then it will take that string and return this thing. So I added two helper functions, serialize helper and deserialize helper. Let's see the serialize helper first. So actually this need to be a field. So initially you just get this serialize function here. So this was empty, so here we need to put that. And what I did, I created one string array and called the serialize helper function, where I'm passing the root and address of this str. So this is kind of the global variables, and I'm using the pointer here in a Golang to maintain this global variable here. Call to the serialize helper function will come here, and then we'll get this 1. So for this 1, that is the integer, so I'm converting this integer to a string, and I'll append this str. So str, whatever I'm maintaining this here, that's the global variable maintaining here. So 1 will be added in that string, and then after that it will call the serialize helper for the left and the right. So left and right, and again when you call the left, again come back to the this value, root value. So this time we'll get the 2 because the left recursion happens, and for the 2 I'll put the 2 in a array, a string array, and go to the left side, right side, and there is a base condition for that. If root is nil, so if you go to the left and right, if you get the nil, then we put the n. So in this way, this function, this serialize helper left call and right call, this will prepare this string array. And if you come to the our original function serialize helper, there is a string. A string is an array of all this value, and then at the end I'm just returning a string. So I'm saying a string start join. So from this string array, I just prepare one string separated by comma. So that's what the join function is doing. It takes the string array and it joins that each value separated by comma. So at the end of this function, I'm returning one string. So this is the serialize string. So next thing is the deserialize. We need to deserialize that. So we have the string, and we need to deserialize that string. So we got the string that is separated by comma. I will write the deserialize helper where I maintain one global variable index here. I'm passing through the pointer. So index first initially I assigned -1, and in deserialize helper function, I'm passing the array. So we know that a string is comma separated string. So that comma separated string, I'm converting this to array. So this is string is split, and that's the array, and I can pass to the deserialize helper function here. So in deserialize helper function we pass that. So first time there's a big string, and the index was -1, and we incremented by 1, so index is 0. So from that string, first it will get 1 in that string, and when we get the 1, we convert that 1 to integer. So that's the function to convert that one string to the integer, and I will create the new node, and the node value has 1. So that will be new node will be constructed, and that will have one value, and then we call the left and right. So because we need the left value and we need the right value, so when you call the left, again this will call, and this time index will be incremented. So index will be 1, so the 2, so we'll get the, in a new node we'll get the 2, and the once the left side comes here, there will be nil in the string. So we're just checking n, so that if it is n, return nil. So for these two it will return the nil. So in this way we call the right recursion, and at the end we can return the root. So finally we'll have the deserialize function that will be able to construct this this tree. So that's a Golang solution here. This is the whole code here. Deserialize and then serialize. So we'll see the Java solution in the same logic I have used. So if you see the Java solution here, there is a serialize function where I maintain one string array and call the serialize helper, and the serialize helper I'll call this, and if it is null in a string we are adding n, and also when we get the value we convert the value to the string array, and we're just putting to the string array here itself, and we call this recursively, and at the end whatever the array we got, we construct one string separated by comma, and we can return that string. And in the deserialize, again for the deserialize function, whatever the data we get, that's a comma separated string, we convert it to the string array, and then there's one index. I maintain this here with the initialize with the -1, call the deserialize helper, incrementing this and constructing the new node, and new node has this value, and call the left and the right, and if it is the string has n, then we return the null. So that's all for today. Thank you.